So conservation of momentum doesn't just apply to collisions where two objects come together. It also applies where one object splits into two separate objects and becomes two objects with different velocities. So initially, we're going to have this plank with a person on it. So that's my version of drawing a person. And this is v is equal to 0, and this is also v, I guess I'm going to call this v1, and v2 is equal to 0. So then p total is equal to m1 v1 plus m2 v2 is going to equal 0. Then what is described about the final state? In the final state, this person is going to start walking. So they're walking with v1. And as they walk forward, they're going to push the plank backward. That was my best hand gesture for that. I hope you got it. So then we're going to have v2. And what do we know about v1 and v2? What we know is this value right here. 1.34 meters per second relative to the plank. That tells me that v1 minus v2 is equal to 1.34. That's not the velocity of the person. That's not the velocity of the plank. That is the subtraction of the two velocities. But then what else do we know? We know that p total is equal to m1 v1 plus m2 v2. Well, let's fill in all the numbers in this equation that we know. Well, we know that p total is 0 because it was 0 before, and now we're in the final state. There have been no forces from the outside world. The lake is frictionless, so there are no horizontal forces to change the x component of momentum. Momentum is a vector. It's changed by force, which is also a vector. So if there's no x direction force, then there's no x direction change in momentum. And this initial momentum is equal to the final momentum. And that is 45 v1 plus, what's m2? 137 v2. So now we have two equations, 1 and 2, with two unknowns. And definitely we can solve them using algebra. Now, the typical method to solve two equations and two unknowns is pick an equation, solve for one of the variables, and then plug it into the other equation. That's called eliminating a variable, because after you do this process, you will no longer see the other variable that you eliminated. So what I'm going to do is I'm going to say, turn this into v1 equals v2 plus 1.34. And I'll plug it in down here. So I get 0 is equal to 45 v2 plus 1.34 plus 137 v2. So then this is 45 v2 plus 45 times 1.34 plus 137 v2 is equal to 0. And at this point, we can subtract the 45 times 1.34 from both sides. What is that? 45 times 1.34 is equal to 60.3. So then minus 60.3 is equal to, and then we can add the 45 plus 137 is 182. 45 V2s and 137 V2s is 182 V2s. So at this point, we can figure out, let me put that over here as scratch work and put that over there as scratch work. At this point, we figured out V2, that's the Planck. And we can get that as a number just by dividing both sides by 182. And then we take that and put it up in there to get the person's velocity. So the key here was to realize what this 1.34 actually means, and it is the difference of two velocities. And that is by a raw subtraction. And then to realize also that conservation of momentum is important. And that's what gave us equation 2, that we ended up saying that the total momentum after the collision also had to be 0, just like it was before the collision. And then you can do the little bit of arithmetic of finding out the final answers to finish the example.